Hey guys, this is Mr. H. Hey, I'm going to do a video on how to complete the square. And I'm going to start it by just starting with how to find the sides of a square if you know the area, because that's the basis for completing the square. So if you see on my whiteboard, there are 6 squares here, and every square has a different area. The number inside is the area of each square. And then on the outside, I have a variable that stands for the length of the side. So on this very first one, I have the area is 16. So if the area is 16, then that means that the side is going to be 4. And the way that I know that is I just have to take the square root of whatever the area is, and the square root of that is going to be equal to 4. So that means that all of the sides are equal to 4. By the way, even though I don't have it listed, all of these sides are going to be S. All of these sides are going to be Y, because every side is equal to each other. All of the sides are going to be X, and I don't have them listed, but you should know that. So this is B, this is B, this is B, this is F, this is F, and this is F, okay? Just so you know that. So in this case, A is 4. Now this one, we're just going to take the square root of the area, so that means X is 5. Okay, that's all we're doing. Taking the square root of whatever the area is. If it's a square, that's how you find the side. So if we take the square root of this one, that means B is going to be equal to 3. If we come over here, if we take the square root of this one, it's going to be the square root of 81. That means S is going to be 9. Okay. And then this one here, if we take the square root of 144, that's a perfect square. That means the side Y is going to be equal to 12. All of these are equal to 12, by the way, just so you understand that. Now, in the last one, if the area of the square is 64, that means that F has to be equal to 8. Now, that's it. Now, we're going to use that idea. We're going to complicate it just a little bit, because that's what we need for completing the square. Now, if you look, we still have 6 squares here, and we have the areas inside, but what we have outside, instead of just having a variable, we have a variable and a constant, but it's still the same idea. So for this one, for instance, if the area of the square is 16, that means we take the square root of it, and that means that this side, A minus 3, has to be equal to 4. Let me make this a little thinner. I like the, right? So, and that means I'm going to add 3 to both sides to get A by itself, and that means the side, or that means that A is equal to 7. Now, each one of these sides is going to be A minus 3, all right? But when you put 7 in there, it'll be 7 minus 3, so all of these sides will result to 4, and 4 times 4 is 16. That's how we know it's right. Now, let me do a couple more. For this one, if the area is 81, we're going to take the square root of it. Now, the sides are S minus 1. It's not S, it's S minus 1. So we're going to set, we know that this side, S minus 1, has to be equal to 9, because that's the square root of 81. And to find S, we just add 1 to both sides. That means S is going to be equal to 10. Now, this is the basis for completing the square. If we know the area and we know the side, even if it has a variable in it, we can figure out what the variable is. All right, one more. If we take the square root of 144, that's going to be 12. So that means this side, remember, all of these sides are Y minus 3. So that means it has to be equal, each side has to be equal to 12, which means that Y, if we add 3 to both sides, that means Y is equal to 15. Now, that's the basis for completing the square. So let's go. Now that we know how to do that, we're ready to complete the square. So here's the first thing we got. Now, I'm going to write up a quadratic. So I'm going to start with this. And this one, I want it to be a little thicker. So this is going to be x squared plus, I'm going to make the b term 20x, and then we're going to make it equal to 21, right? So what this is saying is that we got a quadratic equation equal to 21, and that means that the square plus the rectangle is equal to 21. Now, let me make sure that this is clear. This x squared is just a square with sides of x, like this. So this right here, that area of that square is x squared. Now this 20x is actually a rectangle that has one side of 20 and the other side is x, okay? Now, here is how you complete the square. First thing I want to do is I want to kind of simplify this. All right, so we're going to take half of the b term, so 20. Half of 20 is going to be 10, and it's going to be 10, right? Now I'm going to put a 10 down here, and I'm going to tell you why I'm doing that in a second, right? But now, what we're going to do is we are going to take half of the rectangle, this half, right? I'm going to move this over, and then I'm going to flip it this way. I'm going to make it vertical. And then I need to get rid of this vertical lock. And what I'm going to do is I'm going to move this half of the rectangle right over here on top of the existing square that we have. Okay. Now, can I get rid of this? All right. I'm going to do the same thing with the other half. Okay. I'm going to take this half of the rectangle and I'm just going to move it over until it's flush with the other side of the square. Now, if you look at this, now that's almost a square. I'm missing a piece, but it's almost a square. I just need to add something right here, this part, in order to make it into a bigger square. So I need to find out what's the area that I need to add to complete the square. Now, let me see if I can get this to pop up. Nope, it didn't work. Okay, so I gotta go and grab it. All right, so I need a square. I'm gonna use this one. And now I'm gonna go back here and I'm going to paste it here. So here is the square that we need. So we need to figure out what is this area that we need to add in here in order to complete it and make it into a bigger square. Now, this side is x plus 10. This side is also x plus 10. That means this side has to be x plus 10, which means this side also has to be x plus 10. Now, the area of the blue part, of the blue square, is just going to be 10 times 10. So this is going to be plus 100. Now, what we've done is we've taken the quadratic and we added 100 and we made it into a bigger square. You see that? That's the important idea. Now, if we add 100 to the left-hand side, we also have to add 100 over here. So that means we've got a bigger area now. It's no longer 21, it's 121. 21 plus 100 is 121. So that's our new area. Now, this is the quadratic. That's all of this stuff. But what we're going to do is we're going to rewrite it as a product of the sides. So this is going to be x plus 10 times x plus 10. And that's equal to 121. Now, all we have to do now, let me see if I can, so let me grab this real, oops, didn't want to do that. I want to grab this part and just bring it, I want to grab this part and just bring it down so it's equal. Now, so this is the part we were doing to begin with. Now that we know the area of the bigger square and we know what the sides are, all we got to do is take the square root. I'm going to change this to black. Change this to black. I'm going to take the square root of this side. I'm going to take the square root of this side. We got x plus 10. We got two pairs. So we're going to take that and we're going to bring that out. And this is just going to be x plus 10. And then the square root of 121. That's going to be plus 11. But also it's going to be equal to a negative 11. All right, so we got two equations we got to solve. And the way we do it is we just subtract 10 from both sides, the subtraction property of equality. So this cancels, so we're going to have x equals 11 minus 10 is equal to 1. And then we're going to do the same thing with the second equation. We're going to subtract 10 from this side, and we're going to subtract 10 from this side. So we're going to have a negative 11 minus 10, which is going to be a negative 21. Over here, the 10s cancel. and then this is going to be x equals. Those are our two solutions, and that's how you use completing the square to solve for x. Now, that is the whole idea. You take the rectangle, split it in half, you take half of it here, you take the other half here, and whatever that side is, you're just going to take the square, and that's what you have to add every time. You're going to take half, half, and whatever that half is, you're going to square it to get, that's the part that you have to add to complete the square. Now, you can do this, you can solve this by using the quadratic formula, right? Set it equal to 0, find the a, b, and c. In fact, I think that's a good thing to try. But the whole idea is you can always use completing square to solve a quadratic equation. Just like we can use a quadratic formula, we can use completing the square. We just have to take the b term, split it in half, divide it by 2. That's going to be our new side, x plus whatever that is. And then whatever that b, the half of the b is, we got to square it in order to complete the square. All right, now I'm going to do a couple more examples so that hopefully you guys see what we're doing, but that's it. Once you know the area of a square, you can always figure out the side. That's the key to completing the square. All right, guys, I'm going to stop and I'm going to post this.